Yeah, hi. Let's have a quick look at weather. Severe weather EU. The polar vortex starts to behave strangely, cooling down to record levels and going into overdrive, shaping the weather as we head for winter finale. The polar vortex is starting to power up unusually in the late winter season, reaching record cold level in the lowest stratosphere. This is not without consequences, as it will strengthen the polar circulation into late winter and will be ready to continue into early spring, influencing the weather in the United States and Europe. The polar vortex is a powerful short to medium term weather component during the cold season. It is strongly connected all the way from the ground up into the higher levels of the atmosphere. For this reason, we always take great notice of the activity high above in the stratosphere and monitor it all the time. In the next days, the polar vortex will behave a bit unusual as it will kick into overdrive, reaching near record high power values for this time of year. First, we will quickly and simply learn what a polar vortex really is and how is it so influential. We try to explain this in most of our winter articles, as this is an important part of every winter season. Such powerful yet simple knowledge really helps to understand the bigger picture of how the weather works in the large picture. So, the northern hemisphere polar vortex can be simply explained as a very large cyclonic circulation covering the whole North Pole down to the mid-latitudes. It has a strong presence at all levels, from the ground up into the middle atmosphere, having different shapes at different altitudes. The polar vortex is so large that we have to divide it into two altitude parts. One is the lower tropospheric part and the second upper stratospheric part. The stratospheric polar vortex plays an important role in weather development, while the lower tropospheric polar vortex actually circulates the weather that we experience. But what is the stratosphere? Well, the atmosphere has different layers. Our weather is found in the lowest layer of the atmosphere called the troposphere. It reaches up to 8 kilometers, hence as high as the highest mountains, over the polar regions and up to 15 kilometers over the equator. Above, we have a much deeper layer called the stratosphere. This layer is around 30 kilometers deep and is very dry. The ozone layer resides in the stratosphere. You can see the layers of the atmosphere on the image below, with the troposphere and the weather on the bottom, and the stratosphere with the ozone layer above it. Okay. Here we have the height, 10 kilometers, 30 kilometers. And we also can see the temperature. It goes cold, and it warms up, and then it goes really cold. And then it warms up again, around 100 kilometers. But that's not the whole story. Because, for example, the Center for Science Education has also something about spheres. The thermosphere. The thermosphere is a layer of Earth's atmosphere that is directly above the mesosphere and below the exosphere. It extends from about 90 kilometers to between 500 and 1,000 kilometers above our planet. The temperatures climb sharply in the lower thermosphere below 200 to 300 kilometers altitude, then level off and hold fairly steady with increasing altitude above that height. Solar activity strongly influences temperature in the thermosphere. The thermosphere is typically about 200 degrees hotter in the daytime than at night, and roughly 500 degrees hotter when the sun is very active than at other times. Temperatures in the upper thermosphere can range from about 500 degrees to about 2000 degrees Celsius plus. So they were talking about the bigger picture. That's the bigger picture, a little bit bigger picture. What we had in this other graph from the article as the highest point here, 100 kilometers, is in the bigger picture down here because it continues all the way still up. So they are really just looking basically below the region where it gets hot. I don't know if it's intentional, but obviously it is so. So now we are back at the article. The image below shows a typical example of the upper polar vortex at around 30 kilometers altitude in the middle stratosphere during winter. It has a very nice circular shape with temperature dropping quickly towards its inner core. The strong polar vortex usually means strong polar circulation. This usually locks the cold air into the polar regions, creating a milder winter for most of the United States. As a contrast, a weak, wavy polar vortex can bring very dynamic weather. It has much harder time containing the cold air, which can now escape out of the polar regions into the United States and or Europe. Okay, science behind the polar vortex. Now let's draw something on that. Probably the color you can see. This is the Birkeland current, which moves in both directions. Furthermore, we have the electromagnetic connections which go all around the globe. So the whole thing is really connected to the stars, especially to our sun. And you have to understand this goes through the whole planet. We have the same thing on the southern side too. So if this electromagnetic current, or let's just say electric current, which goes through Earth and has many layers. Actually, I should wait a second. Yeah, I was now searching for a bit. I found that again. So I just wanted to show you a picture. Global electric circuit. This is what I tried to explain before, that we have those magnetic field lines. And they go from the poles all the way around. Okay. That's somewhat funny that that's so lopsided, this sun. Earth. Sun-Earth connection. But anyway. Auroral currents. And this is also really important because here you can see how they are interacting together. Like from really high up, and it goes into the core of Earth. What I try to tell you is that if you see clouds, whatever cloud, it is always an electric current which excites the water molecules, it ionizes them, so they get visible in the form of clouds. And as we watch the polar vortex going crazy, which affects the clouds, which is our weather, you know that there's something going on with the energy circuit of the whole planet. Well, that's null school, that's at the moment. We are watching the highest winds you can get on null school. That's the northern pole with the polar vortex. And on the southern side, there's nothing going on since there is summer. But there's a really big difference, and this polar vortex, as they told in the article, it should be round, but now it's really much elliptic. And our North Pole is somewhere here at the moment, the magnetic North Pole. And there is also this other part of the magnetic North Pole, which is still over in Canada. So we have two poles, that's why the polar vortex is stretched out. And as this is going more south and probably gains also in strength, this other side will disappear. What does that mean? I guess it's bad weather for all of us. But I just wanted to show you like a little bit more about polar vortex than what they were telling us in this article. You can read the whole thing. You probably should read the whole thing and make up your own mind. It's not about me to tell you what to think. I just try to bring forth some things to take into consideration. Because if you haven't knew about those, no one can blame you. Because that's nescience. You just could not know. But if you are aware of those electrical circuits and that the atmosphere extends much more high up than they showed in this first article, and like things, if you know about them and just decide to ignore them, it's not a good thing to do. Don't. Yeah, but I leave it here. Polar vortex. Thanks.